All right, we've got our lesson started today. Let's do it. My name is Shani. I am your teacher, and today we'll be going over number 4 and number 5 in the interview assessment document. So let's take a look. Please make sure that you're navigated to number 4 and number 5. Number 4 starts off by saying this: 2 to the 4m plus 8 multiplied by 9 to the m plus 2 equals 12 to the 3m plus 2. And our goal is to solve for m. So we take a look back, see an m here, we see an m here, we see an m here. And we notice that the bases are all different. Darn! Typically when we multiply things, it's nice when we have similar bases, we can multiply and add the exponents together, or if we're dividing with the same base, we can subtract the exponents, but looks like we can't do that. Again, in an ideal world, if this were 2 to the power of m plus 2, I could combine these by adding the exponents. Here's what that looks like. I'll write it as a comment. If I have a base A, let's say squared, and it's being multiplied by another same base, and it's to the 4th, I can add those exponents and get something like A to the 6th. This would be lovely. It's unfortunately what we don't have. So we see, is there any way I can rewrite these to be like each other? No, but I see a 12 and a 9, and I'm like, those have 3 in common. Can I rewrite those to look like each other? Oh, wait a minute. A 12 is made up of technically a 3 and a 2 times 2, 3 times 4. So we think, how can we break up our 12 in terms of its prime factors? So we're going to rewrite 12 as 2 times 2 times 3. 4 times 3 is 12. Can we do that with 9? I think we can. And can we even do that with 2? Well, we don't have to. That one's a little bit more straightforward. So let's rewrite this problem using our prime factors. Here we go. There's nothing I can rewrite here. I'm going to switch this to a multiplying in that way. The 9 is really a 3 squared. So I'm going to rewrite that 9. I haven't changed anything to the 9. And keeping the exponent the same, this technically still says 9 to the m plus 2. And this all equals, okay, well, let's see. I know that within this parentheses, I will have to make it equal 12. So I'll give you a second to write this down. Since this is a lesson, we're note-taking together and we're working through problems together. There's no stress. We're just talking it out. How can we rewrite 12 in terms of the prime factors? Well, we have a handy here. And since we're getting practice with exponents, instead of writing 2 times 2 times 3, let's represent that 4 as 2 squared. Okay, take a moment, pause. Do we have the same work written down? Take a look. Okay, our goal is to now simplify, basically clean things up if we can, get rid of any parentheses if we can. So I'm going to clean this up by rewriting what I had there. This 3 can have a dropped parentheses by bringing that 2 up. Algebra and rules tell us that this 2 is multiplying by the entirety of the m plus 2. And here I can rewrite my, let's see, let's take a look. Yes, same idea, 2 squared, and it's still all to the 3m plus 2. And that's being multiplied by the 3, which is all being multiplied to the 3m plus 2. Now, again, I want to drop my parentheses if I can. So again, I see parentheses right here. So take a pause. Do you have the same thing written out as me? Okay, let's see if we can drop our parentheses. We rewrite everything. It is really important. Well, how do we distribute this? I will use another color. 2 needs to be distributed to both the m and the 2. We're about to do the same thing over here once we get there as well. 2 times m is 2m. 2 times 2 is 4. Let's do it again. 2 times 3m, 6m. 2 times 2 is 4. And since the 3 has nothing multiplying through, or technically a 1, we can just go ahead and drop those parentheses. All right, we're feeling good. Everybody give me a thumbs up if you're feeling good. Thumbs up. If you're somewhere here, show me now. And now's a great time to pause and ask for questions before we start to simplify further. What questions do we have? Okay, here's where it gets to be even more fun. Are we ready? We're noticing a same base and a same base. And here I'll do a squiggle, same base, and squiggle, same base. If this said something just like 2 times 3 equals 3 times 2, I know that this is a true statement. Huh. If it just said 2 equals 2, I know that this thing is equivalent to that. So in this case, we are forcing equivalency. We see it here. And we are equating this guy to this guy. We're equating the exponents of the 2's and equating the exponents of the 3's of the bases. So let's try that. Let's start with the 2's. We can even write a little comment. Equate the exponents for each base. It's nice to write this in your notes so we can look back to it. Equate the exponents for each base respectively. Okay, I see a 4m plus 8 for that 2, and I'm going to set it equal equating to 6m plus 4. Now it's a matter of algebra. I can subtract 4m on both sides. I can subtract 4 on both sides, and this leads me to m equals 2. Very cool. We rearranged. We can do the same thing here and just check our work. Let's see. 2m plus 4 equals 3m plus 2. I can subtract 2m on both sides. M equals 2, no matter which one I equate. Awesome, awesome work. Okay, I am now going to take any questions we might have. Before we get on to number 5, let's take a look. A little recap of what we did. If this were class, I would give you a recap. And we're going on to problem number 5. We now will use orange for this color for problem number 5, and we're going to have fun doing it. Okay, problem number 5 tells us that A, B, and M are integers. Okay, what are integers? Who can tell me what an integer is? What's an integer? Thanks. Yes, I love how you gave that answer. Integers are numbers. They can be positive, they can be negative. Thank you. Give me an example of an integer. Great. All right, and then it goes on to say that x plus a times x plus b equals, woo, let's go. And it says to find all possible values of m. Okay, what does that mean? Find all possible values of m. Well, I can play around with this quite a bit and just see if I can magically get this side to look like that side. And we can do what we just did in the last problem of equating things. So let's see. If I were to distribute here x times x, foiling, x times b, okay. A times x, ooh. And then a times b, a, b. Darn, this does not look quite like x squared plus mx plus 12. But I can set this part equal to that part and maybe equate this to this, perhaps? That might be an option. I'd like to see it a little bit more clearly. You see how this m is sticking out right here? I would like for this to just kind of say x, and then there'd be something in front here that also just kind of sticks out. How can I do that? I'll write it down and give you time to think about it. How can I make this part of the expression equivalent to the one above it by yanking or factoring or dividing out an x? What must remain? What do you think? Great. Thank you for telling me that. I can write the B and the A because when I boil it back through, it's still XB plus XA. And in this case, yes. And since I like the alphabet A, then B, I'll write it this way. Either way, I still have an XA and an XB. Hey, if you wrote AX, that's okay. A times X is the same thing as X times A. All right, we're getting closer to seeing that this is very similar to this. Let's mark it in another color so we clearly see it. This is equivalent to that. And this is equivalent to that. We can come up with two equations and we have two unknowns. So let's solve. Our first equation will be this guy. A plus B equals M. The thing in front of the X equals the thing in front of the X. Great. I'll go ahead and label this equation number 1. What's equation number 2? Well, I'm getting it from this AB and 12 business. So AB equals 12. We are equating this side to that side. Our goal is, again, to solve for M, but we need to know what A and B integers are that we can get an A plus B equals M. So first, let's start actually in equation 2. Because I know nothing right now about A and B and M. How can I choose two things that add up together to make one other thing I also don't know about? So I'm kind of stuck there. There's nothing I can do. Let's move over here. I still don't know what A, B are, but I know that there are two numbers that can multiply to make 12. So like 1 times 12, the A might be 1 or the A might be 12. What else multiplies to make 12? Oh, thank you. 2 times 6, 3 times 4. Anything else? Looks like we've got it all covered here. Oh, someone just mentioned negative numbers. Okay, so I can have a negative 1 times a negative 12, right? And that still makes a positive 12. Negative times a negative. I can have a negative 2 times a negative 6, and even a negative 3 times negative 4. A can be this or that, this or that, this or that. Let's see what the integer pairs are. So again, it could be 1 comma 12, 2 comma 6. You can write these as a long list. Possibilities. Great. Now we have to take what we know from here and put it into this equation and make sure that it makes sense. If this is A and B, will it add up to be M? Well, we don't know what M is, so we're again stuck here. We just have to claim that whatever we get is what M could be. So let's do it. Our first one, 1 and 12. 1 plus 12 equals 13. Yeah, M could be 13. What's our next one? We got this one covered, 1 comma 12. 2 plus 6, great. M can equal 8. We're starting to see all our possibilities of M. Okay, you keep going. 3 plus 4 equals 7 can be a possible M. Negative 1 plus a negative 12 is a negative 13. We'll also start to see the pattern that we are getting the negatives of what we had just received. These are all possible M values, whereas this one here were possibilities of A and B. I'll take a pause for any questions. What questions do we have? What questions do we have to take a look? We clearly showed our work all the way through from beginning to end. We had fun doing it, and we did such a great job. Congratulations. Thanks for such a great class, everybody. I hope you have a great day.